So you must be preparing for the hackathon, which is going to be on 19th. It's a Sunday. I hope all of you have unofficially got the information, but officially I will be sending out an email as well. Most likely the time will be from 11 o'clock. So it's better if you come here at 10:30. Make sure that you occupy your PCs. It will be in two classrooms, I mean, two labs. We'll announce the venue soon. Once it is fixed, all of you will get the official information. So that's for the hackathon. The second thing that you should be working on right now, you should have started working on right now, is the coursework 2, which is 60% of your overall assessment. You should start exploring your data. You should be looking at, knowledge building, domain knowledge. You should also have started thinking about how logistic regression can be applied, how categorical prediction can be applied to your context, even if it is not directly there. How can you have a use case that can have some categorical prediction? So start thinking in those lines and start preparing for both of them. Do remember for the hackathon, the mock hackathon will be there, which will give you enough practice on what to expect, how to do the submission. We will do much more briefing before the mock hackathon so that you're prepared for the final hackathon. We have completed regression as an algorithm, but it was more on Excel, not on data IQ. We have moved on to logistic regression that also we have completed, which is a categorical prediction supervised learning. And today we'll be starting a new algorithm, which is called decision tree, and it's going to be on brand new data. It's going to be a new project that you will be doing. So after today's session, actually you will have two more algorithms in your bag, which is decision tree and random forest. I'll tell you the difference between these two. And once we import our data, we start practicing with it, you'll understand, the use case that you're going to see today. Before we proceed and get started with decision tree, do we have any questions on the module? Anything anyone wants to clarify so far? I understand some of the permissions on the Data IQ platform might be here and there, so I'll just have a look after the session, but at least for today, it's a new project, so you don't have to revisit any of your previous projects. So you should just start a new project and you should be okay. Let's get ready for the decision trees. In order to get ready, I want you to download a data set, which you can see in decision tree, week 6 folder. And you will see credit card UAE sign up. And you would see credit card metadata. I want you to download both of them, not upload it on Data IQ yet. Metadata is telling you what the columns are, and credit card UAE sign up is the actual data. I'll tell you more about the data set itself. Just download it, keep it ready so that we can get started. So in week 6 folder, once again, you'll be able to see credit card UAE sign up, CSV, and one Word doc, which is called the credit card metadata. That's the one that we're going to use today. Okay, so let's get started with a new algorithm called decision tree. Anyone needs any more time to get ready? All good? Okay, so full attention here. Let's have a look at what is decision tree, why is it needed, what kind of algorithm it is, because you need to map the right things at the right place. But before we get started, quick recap on logistic regression, and let's see if anyone remembers logistic regression. Utkarsh, we'll start with you. Can logistic regression predict numerical data? So, for example, I want to predict the revenue of a firm next year. Can I use logistic regression? Why?
It's like one or 2 years.
Correct. So a better way to put it, logistic regression can only predict what kind of data? Categorical data. Anything which is numeric, what is the correct algorithm there? Regression, linear regression, exponential, whatever we have seen earlier. Those are all the examples where you predict a numerical outcome. Okay. Both regression and logistic regression are the examples of supervised learning or unsupervised learning. supervised learning, because in both the cases, you're predicting one variable. Everything else is helping you predict that one variable. Akash, right? Tough question for you. So in logistic regression, I have done logistic regression, I have got the equation, everything is there. When I put the value of x1, x2, x3, x4, whatever the independent variables are, what do I get as an output or as a prediction? So in regression, for example, when we did sales and number of days, when we put the day number, we get the sales. We get y as the final prediction. In logistic regression, what do we get?
Dependent variable.
Great answer. Great answer. You get the probability of the dependent variable. You don't get directly whether someone would survive or not, whether someone would default a loan or not. That's up to you as a human how to interpret it based on the probability. Actually, to be more mathematical, you can say when you put the value of x1, x2, x3, x4, you actually get log of odds ratio of y from which you can calculate the probability. But at our stage, good enough to understand that it does not give direct prediction as an outcome. It gives you the probability, and that is very, very important to know about logistic regression. There is some confusion going on. May I help you?
No.
But what is happening? All good? You're still on superset or you're on decision trees?
No.
All right. Okay. What else? What else? Very early. Half an hour. Okay. So, is there any? We'll ask. I forgot your next one. Abhishek. Yeah. Is there any restriction on independent variables when it comes to logistic regression? Like what type of independent variables can go into the model? Can it be numeric? Can it be string? Can it be categorical? What are the rules for independent variables? X1, X2, X3. Okay, I'll ask you one by one. Can we have numeric variables? 100%. Great. Can we have categorical variables in independent? Yes, we saw that in Titanic. What was the independent categorical variable? The groups, the P class, and then gender was also categorical. So definitely you can have categorical. Can we have text as independent? String? No, definitely not. Unless it is categorical, like male or female. So you would say it is categorical, not like name of an individual can never be, one type of independent variable. So any other questions on logistic regression before I move on to decision tree? All good? So let's introduce a new algorithm, which is called decision tree. For any algorithm, you should first map in your brain, is it supervised learning or unsupervised learning? Okay. Then you should map, if it is supervised learning, can it do categorical prediction? Can it do numerical prediction? Let me reveal what decision tree can do for you. Decision trees will do exactly the same job as logistic regression. Absolutely no difference. Whatever logistic regression is doing, exactly the same purpose is decision tree. So, does that make decision tree supervised learning, unsupervised learning? Supervised learning. I said exactly the same use case, exactly the same categorical prediction, exactly the same independent, everything is the same. So definitely supervised learning. Can it be used for categorical prediction or numerical prediction? Exactly the same as logistic regression. Categorical prediction. However, there is a variant of decision tree which can be used for numerical prediction as well. Those are called regression trees, which we are not looking into right now. But as of now, you can just assume it's a plain substitute of logistic regression. Now you might ask, if it is exactly the same as logistic regression, why do we need another algorithm? And I think it was you who asked, or someone in the other batch came and asked a very interesting question during the break when we did logistic regression. And I don't know if it was you, I fairly remember it was you, but maybe I'm wrong. So the question was, in logistic regression also, at the end, you're fitting an equation, right? You're doing x1, x2, x3. There is a sort of linear relationship that you're looking at. The only thing is your dependent variable is log of odds ratio, blah, blah, blah. But still it is equation at the end of the day. And the question was, what if your data is not good enough to fit that equation? I mean, there is still a possibility that you might not get beautiful equation, but still logistic regression will try and fit that equation and will give you somehow. And that's what I told you about AI. It never says no to anything. Whatever you do, it will fit it and it will give. You saw that in the exponential distribution in regression, right? Even if you fit linear, it still does it, right? And if you do exponential, it does it better. So now, is there anything else other than logistic regression which can work better on those data sets where you don't have a clear-cut equation, like something x1 plus something x2 plus something x3? Is there a different way to learn? We are all doing machine learning, right? Is there a different way to learn but still achieve the same objective? The answer to that question is a new algorithm called decision tree. Let me show you first how a decision tree looks like, and then you tell me how is it learning? How is it different from logistic regression? So, for example, I'm doing a prediction on whether someone would vote for an election or not. Okay. The independent variables are gender, income, and age. All right. And now I use a decision tree and I'm saying, can you do some prediction on whether a person would vote for an election or not? Now the algorithm did its job and gave you an output like this on your screen. Why are you clicking? The PPT is there on why learning. You don't need to play. Yeah. So now the decision tree has done the job and given you the output. Let me hear from you. How do you think it has potentially learned differently and expressed differently compared to logistic regression? Who would want to start? Maybe, but let's assume it could miss out many categories, which is good. But let's assume it's only gender, income, and age as x1, x2, x3 that I do. And the dependent variable is y, which is someone would vote for the election or not. So let's assume there are 3 independent variables. Then can you tell me how is it learn differently, express differently? This is the final output, by the way, of decision tree. This is what it gives you at the end of your machine learning. All good there? Any problem? All good? Yeah. Who can attack? Kartika. Okay.
Constant values that are there in regression. So by migrator or 45,000.
Okay, good guess. Okay. Okay, very, very close. So let me ask another question and everyone listen carefully. Let's assume the same thing, which is prediction of whether someone would vote for an election or not, with 3 variables, gender, income, and age. Let's say the same thing we did in logistic regression. Okay. How would logistic regression give you an answer? In probability. So it would say log of odds ratio of someone voting for an election is something gender plus something age plus something income. It will give you a proper equation. You put the gender, you put the age, you put the income, it will give you the probability of someone voting for the election or not. It has learned and expressed in the form of equation. You put the value of x1, x2, x3, and you get the value of probability of y. Here, what is happening differently? Where do I put the value of X1, X2, X3. So if I'm asking you, hey, there is a new person and this person is a female and has an income of 48,000. What will be your prediction? She will vote or not vote? I'm telling the person is, the gender is female and the income is 48,000. Based on the output, how do you put? Not vote. Let's have a look. So gender is female. That's your first thing. Now it says, okay, check the income. If income is greater than 45,000, then the prediction is the person will not vote. Okay. Now, notice the difference. Difference number one. In logistic regression, there was a proper equation. Something x1 plus something x2, something x3. In decision tree, if you notice what is different, there is no equation. It is if else, if else, if else. It's actually a combination of if else statements, right? Have a look. If gender is male, then check the age. If age is greater than 40, person will not vote. If gender is male, check the age. If age is less than 40, person will vote. If gender is female and income is greater than 45,000, person will not vote. If gender is female and income is less than 45,000, then person will vote. Eventually, it is if else, if else, if else. The learning in logistic regression was with the help of an equation. The learning in decision tree is if else, if else, if else, if else. Good news, you are not finding if else, if else. Algorithm will learn the patterns from the data and give you a series of if else, if else, if else, which is accumulated in the form of a tree. And that is why the algorithm is known as decision tree. Now, if someone is asking you, what is one stark difference between the prediction of logistic regression versus the prediction of decision tree? What would your answer be? There's one big difference.
The probably decision tree gives series of answers.
Okay, but it still gives one answer. See, I told you that there is a female with 48,000. So there is only one answer. Each will give, which one will give you a direct answer? Decision tree. That's the major difference. In logistic regression, it never gives you the direct answer. What does it give you? Probability that an event can occur. In decision tree, it says, I'm not into this probability game. I can only give you yes or no. Now, which one is beneficial, which one is not, really depends on the case, right? For example, if it's a loan default, a manager would love to know the probability, would love to know, whether it is 0.55 or let's say 0.9. There could be a huge difference. Something like a bank fraud detection where equations are not fitting in, you would want to know the direct answer. Could it be fraud? Could it be not fraud? Again, probabilities could be important, but the data itself might not be good enough to fit the equation, right? So in certain cases, you're not very sure of the distribution of data, the normalization of data, and you would say, I don't trust the equation being so good. I would rather fit the data. This is called fitting. It is purely learning from your existing data. It's finding the combination of if else, if else, if else, if else, which truly fits your data. Yes, it might not be as generic as logistic regression. It is very, very customized to the data that you're looking at. Nothing is right, nothing is wrong. No one can guarantee in which case you will get more accuracy. Sometimes logistic regression can give you more accuracy. Sometimes decision tree can. No one can put a stamp and say, this is the best method for this. So ultimately, what do people do? If there is no authentication on which algorithm is the best? Try both. Absolutely. Try both. See whether the equations are making sense. See whether the coefficients in logistic regression are making sense. See whether the tree makes certain sense and so on. So usually people try both. One thumb rule is whichever you get more accuracy, you want to align more on that. But that's not the only rule to decide which algorithm is the best. It's ultimately an analyst's decision on which algorithm do you trust more. Questions?
Logistic regression. We can see the accuracy of like we needed regression or logistic regression. There's accuracy that we can check. That's we class for value of your
Correct.
yeah.
The alternate form of R square, correct.
In decision tree, what's the form of accuracy?
Very good. So now this is a big question in terms of what is, so I would say accuracy, I would reserve the word for the training and testing accuracy, which is the same in decision tree. I would say the model robustness, which is R square in logistic regression, McFarland R square, R square in regression, McFarland R square in logistic regression. In decision tree, they call it something called error term. But again, just like logistic regression, it's not a very reliable parameter because ultimately there is no equation fitting here, right? It is just if else, if else, if else. It learns from your data, it fits it, and in fact, on many occasions it could overfit, which means you could see everything is good, but maybe in a generalized format, it's not so much. So the model reports error term, but people don't usually consider that as strong a measure as R square. They would say, this is ultimately if else, if else. But if you talk about accuracy, the concept remains the same. You have a training data, you have a test data, run the tree on training data, check the results on test data, see the accuracy on the test data. Yes.
So, in logistic regression, we feed in certain independent variables and check the probability of the event happening.
That's correct.
And once we run the logistic regression, there is a percentage distribution as to which variable has the most effect.
Absolutely. Great.
So is there anything backend that happens over here that
Yes.
basically the coefficient that is there in logistics?
Very, very nice question. And I love this is how you should be thinking. Now, great question. In terms of decision tree, now what happens is generally you don't have coefficients that can tell you, oh, these are the top three variables. Okay. But there is something else. And let me ask you this question. Let's assume that I took 6 independent variables: gender, income, age, let's say, what are the other things that could influence voting? Education. Let's say I took education. Let's say I took another variable called years of experience in working, let's say, and still I got the same 3. Which means I took 2 extra variables, but as you said, those 2 variables did not feature in my tree. If they don't feature in my tree, that's the first indication that those 2 variables were not important in classifying something as yes or no. That's indicator number 1. So if you take 10 independent variables and only 4 of them feature in your tree, the other 6 were not very, very important. That's one way of interpreting. The second way, and let me ask you this question. Out of gender, income, and age, which one do you think decision tree considers as a more important variable? Gender. Wherever the tree starts with splitting, and this is all mathematics, by the way, okay? So how does it choose gender as the top variable? Because you did not say gender is 1, you did not say income will come later, age will come later. You never said that. You gave everything. You gave gender, you gave income, you gave age. But it started with gender as the top variable. The moment it starts with gender as a top variable, which means majority of your data can be classified into yes or no by purely gender as the first variable. And the moment you see gender on top, you would say that is likely one of the highest contributing variable without even looking at the coefficient, because here there is no equation, so there is no coefficient. So what data IQ does very smartly, based on the splits, based on number 1, number 2, number 3, it automatically ranks again. So when you see the result of data IQ, you would say, oh, here also I'm getting the same thing, which is important, which is second important, which is third important. But remember, those are approximations in decision tree. There is no coefficient that can tell you, oh, this is 2.5 times, this is 2.1 times. Those are interpreted from the levels, and then result for you remains the same. You will still see, okay, these are the top three, these are the bottom three, but they are all interpreted from the tree. So in this case, I would say gender is the top variable, income and age almost at the same. But again, I will see how many it could split with income, how many it could split with age. Good news, I don't have to see. Data IQ does everything. It looks at the tree, it looks at the results, automatically ranks everything for you. So for you, nothing changes. The result of logistic regression is the same as decision tree. The only thing you would miss out on is the regression coefficients, because that doesn't apply to your decision. Very good question. Also, by the way, some people said, oh, no, I still want probabilities of prediction. I don't want the direct answer. So data IQ says, okay, I can calculate the probabilities for you, like based on the split, how much it will go here, how much it will go there. It does report probabilities, but those are not the actual probabilities because there is no probability. It's a tree. It's a yes or no, which is the direct prediction. So if you see probability in decision tree, don't get shocked and say, oh, where did the probabilities come from? Those are inferred probability, which data IQ is doing, trying hard to give you everything like logistic regression. But in short, decision trees are not meant to give you probabilities. It's direct answer. Rain or not, pass or fail, vote or not vote. You get direct answers when you go for decision tree. Very good question.
So trying to take the decision tree over here, gender has been classified the male differentiator.
Correct.
And under that, for the females, it's income that makes a difference, and for the males, it's age.
Age that makes a difference, 100%. So from the existing data, that's how it is learning. That's how the existing data can be classified. Whether truly it represents unknown data, futuristic data is something that you'll have to contemplate. Maybe logistic regression does that better. So generally when we run, you have the option of doing both. You can switch on decision tree, you can switch on logistic regression, compare the answers, see which level is. In fact, you can see the whole tree in the output of the decision tree. It actually draws a whole tree based on your data. It predicts for you everything it does. But you should know that the backend of a decision tree is if else, if else, if else, if else. The backend of logistic regression is an equation where you have x1, x2, x3, the coefficients that leads to the probability. Any other questions? Yes. So it's great question. Now, if you're looking at a new profile, which is female, and what give me an age? Let's say 50, right? You again start from the top. You follow the tree. Okay. So I start from the top. I would say, is the customer, is the person female or male? In your case, it is female. Now check the age. Age you said is 50. So age is not there. I'm not checking the age. What is the income of that person? So then you cannot predict anyways. So then it's the same case for logistic regression also. You need all the independent variables. So for example, you ran logistic regression, okay? And in Titanic, you don't have P class of a passenger. You cannot do the prediction. You need what independent variables are there for prediction. You need all the independent variables. If one is missing, it's missing. Yeah.
What is the income is 50,000, but the age is 25.
Does not matter. So tree is only checking, it looks at your profile and it says, okay, what is the gender? Female. And then what income you said? 50,000. That means no, irrespective of what the age is. Does not matter. That's how it has learned. Is it correct or not? We don't know. It has read, it has understood your existing data, formed if else rule, and very, very important to know that if else rule is 100% accurate on your training data. There is no customer or there is no person in your training data that will violate this rule. It learns 100% from the existing data and forms rules accordingly, which means if there is a female, then age is irrelevant in calculating the income. Now, whether it is truly irrelevant or not, you would never know. In the existing data, I had 500 customers. In all 500 customers, if a person is female, age is irrelevant. It can be multiple. And even so, guys, that's a good question. It can be multiple. This is a very simple tree. You don't get a tree like that. So it could be if it is gender female, then check income and check age. If age is this, in fact, the variables can also repeat. Like even after income, the next could be check age again. If age is this, if age is that, in a realistic situation, that will always happen. You'll never have a beautiful tree. In fact, you'll see today we are going to do a credit card data. The tree is such complex that we like, 40 levels of the tree, variables repeating all over again. It's because it's if else, right? And it 100% matches, which means every single customer in your data set will follow that rule. And that's machine learning. It brings out that rule for you. So great question. Yes, this is not the kind of the tree that you would ever expect in a decision tree. In a realistic data, it will be all mixed up. Income will be there. Then it will say, okay, check age, and then it will say, check this, check that. So lot of branches, lot of complication. Finally, you will get an answer whether person would vote out. Anything else that I can clarify? No questions? So summary, decision tree, exactly the same purpose as logistic regression, which means now you have two algorithms to play with. In fact, let me add a third algorithm right now, which you saw last time when we were running logistic regression, something called random forest. Now, what is random forest is something interesting. Forest is basically a collection of trees. So what random forest does is it looks at different training testing combination and forms different decision trees and chooses the one where it is best representation of your data. So it's not just one tree that it is looking at, it is playing with multiple trees. So if you're doing that, that is called random forest. Generally, people prefer random forest because you choose the best tree possible with all the testing training combination. But as of today, we'll only experiment with decision tree. If you want, you can switch on random forest also in case it can come up with a better tree representation for your data. 100% supervised, same as logistic regression. You still are doing categorical prediction, only one variable. No unsupervised here, nothing. There is still one dependent. There are still many independent. Everything is the same as logistic regression. The learning is different. The expression of the output is different. Learning is in the form of if else, if else, if else. Output is in the form of a tree instead of an equation. So no regression coefficients, no R squared, no concept like that. Just a tree, which is if else. Correct. 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 We don't vote on test anyways. We never build the model on test, right? So a great question. Now, if imagine this decision tree in the Titanic context, which is what you should be experimenting later. Okay. Now, if you're doing Titanic with decision tree, everything is the same. You do a train, you do a test, you split 80-20. Instead of running logistic regression on the training, now you run decision tree on the training. So it will make a tree if maybe it would say if it is gender. I also believe that the tree could have ideally or would ideally start with gender and P class because those are the two most important. So let's say it says if you're a female, then check the class. If you're a male, then check the class. If class is this, if gender is this, if age is this, etc., etc. It will form a tree, and at the end, it will give you whether the passenger will survive or not. So no difference in the process. It's the same. Correct. We gave unknown data. Correct. Correct. Different. So output will be different. Predictions will be different, but process is the same. So you have an unknown Titanic data. Instead of passing that unknown Titanic data through an equation, now you will be passing it through a tree. And tree will give its prediction. The equation's prediction could be different, and that's why the algorithms are different. Accuracies are different. At the end, you have to take a call in which algorithm do you trust. So predictions will be different, and not alarmingly different because in Titanic data it's quite well organized. So minor differences can always be there. and would be there because you are testing it on a different scenario. In case one, you are passing it, you are putting the value of x1, x2, x3 and getting the probability of y. Here, you are doing if else, if else, if else and getting the value of y. If the process is the same, output will be different for unknown data, definitely is.
So when you're doing, working on a post, would you suggest, passing the data through logistic regression first, so we have a better clarity in terms of numeric values? So when we're doing a decision tree, it gives us a better idea of what to expect.
You are thinking in the right direction and fantastic. That's generally how we do. We first do logistic regression, understand the importance of the coefficients, and then try and validate that with decision tree and check if the top 3 or 4 levels of the tree are actually matching the top 3 or 4 of the logistic regression. Then you have a better confirmation that you are looking at the right set of independent variables which are making a difference for dependent. However, let's say you ran logistic regression first and you observed everything is here and there. The accuracy is bad. The coefficients, whatever you thought are not the coefficients or are not the variables which are impacting. Then you would say, maybe the equation is not a fit in this context. I would rather trust the results of decision tree. So if logistic regression is working well, you would consider decision tree as a validation to that. If it is not working, you would just say no to logistic regression. You know, equation is not the right thing in this context. So you would rather trust the results of decision tree. So generally that's the process. Because logistic regression is more mathematical oriented, so giving you higher chances of generalizability compared to a decision tree, which is if else, if else, if else. Could work, could not work. But risk is more in decision tree because it's just learning if else. Anything else?
So for day-to-day, we have multiple variables and
Correct.
good to run both.
Generally, and that's why data IQ and all the other tools. So in coding environment, this was a big challenge, right? Now you would say, oh no, now how do I run both together? I write a program for logistics first and then write a program for decision tree. It used to be a pain point for people. Now switch on both and see the results together. So why not? Yeah. When the tool allows you that flexibility, great to run both the algorithms together. Shall we get started then? Yeah, all right, let's do this. Good questions. I absolutely love the questions that you're asking, and that's exactly the way you should be thinking. So let's make a new project. And let's import our data. Just a reminder, the data set is credit card UAE sign up. That's your data that you're working on. I'll just rename this as card. You can retain the original name, no problem. And click on create. Let's see. How many of you are ready? 15 Sorry.
Yeah.
Let me explain what the scenario is. In fact, in the other batch, there was one student who asked, okay, Titanic data is great, but in a realistic situation, you wouldn't want to predict passenger survival. And that was just to get you started. Now we will look into more of a realistic scenario where predictions would make a lot of sense. Once everyone is in, I'll explain what it is. We'll set up everything and then take a break and then. Yes, that's the one. You can bring it in. Create, yes. Well, good, loaded. Perfect. Everyone is in. Now, let's have a look at what kind of data we are looking at. So you see every row, and that's how you start thinking about data. What is represented in every row of customer? Customer one, customer two, customer three, which means I'm looking at a customer data, clear cut. Now I look at what are the attributes of the customer. Okay, so I have age of the customer, income of the customer, marital status, job type. These are all self-explanatory. So you don't even need to check that metadata to check what these columns are. Whether the person has a loan with the bank or not, which is a yes or no. You have the credit score of the customer. You have number of visits to the branch. You have average online spending of the customer. You have the emirate that the customer comes from, number of children, shopping interest, total years in the UAE, and then the most important column. And listen to this very carefully. This is where the case study starts. Now, what this bank did is they launched a new online shopping credit card. Now, a lot of these banks are doing this. For example, Emirates Islamic has Emirates Islamic Cross Amazon credit card, which gives you a lot of rewards for Amazon shopping. Mashriq and NBD has NBD Noon and Mashriq Noon, which gives you a lot of rewards for noon shopping and so on. So a lot of these banks are now experimenting with collaborating with the online shopping one company or maybe a group of companies and then launching the credit card. Okay. Now, what do you think this last column represents? Whether they took this credit card or not, which means they have tried this across many passages. Okay, they have, tried this across many customers. Some of the customers said yes, I will go for the credit card, and they have taken the credit card. Some of the customers have denied, I don't want this credit card. That's what you see as the last one. Signed up for that credit card or not. Okay. Now, difference between hackathon and coursework 2. If this was hackathon, I would have given you the objective. And the objective here, what we are going to do today is, now the bank is interested in making a prediction model that whenever they are thinking about a new customer, will this customer buy that credit card or not? And it's a great insight for the bank. Okay. For example, now when you open your banking applications, I don't know if any one of you have those banking applications here. As soon as you open, there is a product ad which is placed to the customer. There is this new credit card, do you want or close it? Now, imagine if the customer is not at all a likely candidate for buying that credit card, you're still pushing ads and you're still pushing those pop-ups. It would irritate the customer and they would say, I came here to check my bank balance and suddenly you're giving me that, do you want to buy this credit card? This is waste of time. On the other hand, if customer is genuinely interested and has a high chance that, I'm interested in online shopping, I'm looking for a credit card, one pop-up could make a difference. I would say, oh yeah, this is the kind of card that I want. I can click and go for it. Within the banking application, predicting whether a customer would sign up for a credit card makes a lot of sense. Outside the banking application, ads. Should I send customized ads to the customer? Are they likely to make a purchase? Should I not spam them? Should I be calling them? Should I not call them? All this will depend on what is the probability or what are the chances that a customer would ever sign up for that credit card or not. And this is where the game begins. In hackathon, I have given you the objective. That's the model that we are going to build. Is it supervised learning? Unsupervised learning? Definitely. It's one variable that I'm interested in. Everything else is helping me predict that one variable. Is it categorical prediction? Numerical prediction? Categorical. Whether the customer would sign up for the credit card or not. 100%. Can I use regression to solve this? Can I use regression? Regular linear regression? No, because regression can only predict numerical values. Can I use logistic regression?
Yes.
Can I use decision tree? Yes, both are substitutes of each other, which means in this use case, I am thinking of both the methods. In fact, we can try both. First, we'll try decision tree. In the next trial, we can run logistic regression and we will compare the results. If this was your coursework 2, then I would not have told what you're predicting. That's the kind of data that you're given. Now you could come up with many use cases. So this could be one of the use case. Oh, I could actually predict. And this use case makes some sense, right? Because you have a lot to invest on, you have a lot of decisions to take based on that. So you formulate your own use case in coursework 2. In hackathon, we give you what you're predicting. Clear so far? Okay. Now I need some inputs from you. First impressions of the data. Yeah. In age. Fantastic. You guys are expert now. So first impressions of data. Sorry. Let's look at age. Yes, you're right. There is some missing value. And what else did you say? Income. Yeah, there is some. Yeah. Okay. Perfect. Others look okay. Full green. Everything else is full green. Fantastic. So first impressions, there are some missing values. I need to take care of missing values. I would. Second impression, from a case study point of view, I would start looking at each column. Okay. Without doing the pivot table today, just by general knowledge, which variables do you think can be useful in predicting whether a customer would sign up or not? Let's start from the first one. Customer ID. 100%. Why would ID be important in predicting? Number two, age. Possible, definitely possible that age patterns reveal shopping behavior. Shopping behavior could predict whether someone would buy. What else? Income?
Yes.
100%. I would definitely want to take marital status. Maybe, maybe. Well, I'm not a very great candidate, but could definitely play a role, would be worth checking. Job type. So even if it is, the problem is there are too many job types, like there's sales, IT, and this and that. If at all I want to take, maybe I will cluster it a few more. Maybe, let's say clerk and, one type of job, I would say type 1, type 2. But because there are many types, I wouldn't want to experiment. Maybe a refined form of that I could check later. But as of now, not very keenly interested unless pivot tables tell you something else. Same for all? Yeah. So then.
At the same time,
Hmm.
income is almost the same. Like the income is more, prominent, and the job type, if, like,
Job type you're saying could be more important? No.
because we're considering income,
Correct.
corresponds to the job type.
Very good. Yeah, and that's one of the other explanations. Absolutely. So if you're taking income and job type, depending on, and it's the same country, by the way. So, the fluctuations will not be higher in terms of clerk in one country versus clerk in another country. So you're right. Job type, I would not be very keen, and there are multiple reasons for it. Has loan with the company. Maybe, may not be. I would love to do a pivot table here. I would see how many those who had loan went for the credit card, did not go for the credit card. How many who did not have loan went for the credit card, did not go for the credit card, to check if that really in this customer data makes a difference or not. Credit score? Yes, possible, definitely. I mean, that's the spending behavior. Visits to the branch? I don't think so. I mean, does not truly represent a shopping behavior of a customer. Average online spending? Yes, definitely yes. That's a strong variable. But again, I will have to be careful about any correlations, which I'll see later, to make sure that I don't plug in two variables which are almost the same. So I would be a bit careful, but yeah, definitely one of the strong candidates. Emirate? Probably, maybe in Dubai and Abu Dhabi, chances are higher. Maybe, may not be. I'm not so sure. I will again do some pivot tables, figure out are there any.
This is from where which highest credit card has been
Signed up, yeah, exactly. So then it would be, so pivot tables, I would do pivot tables, I would check in which Emirates more signups are coming, less signups are coming. Maybe, may not be, I would look at it. Number of children, maybe, may not be, not a very strong candidate, but yeah, one logic says if you have more kids, you do more shopping and things like that. So we will have to check. What about shopping interest? Could be, but how? Even if it could be, can I do it? Why can't I do it? It's a text. It's a classic string. It's almost like a review of a product. And this is not categories, right? This is random text. So you're saying customer one is a frequent traveler, books via booking.com, clear trip, goes to Mall of the Emirates. This is a string. And you can't have string as one of the independent variables. So what do I do? Sure. How? What kind of things you could do here?
Say,
Keywords, and this is what we are going to experiment. So I would say, let's say in this context, it's not clear which particular shopping cart was this one. But let's say if it is online shopping cart, you're looking at Noon, you're looking at Amazon, you're looking at few others, and I could simply use a if-else statement. I can say if your shopping interests consist of the following keywords, which is Amazon, Noon, and maybe some other. I can check what are the frequent keywords. Then online shopping interest is high, else online shopping interest is low. I can create one more column, which is high or low, and maybe that could be a very, very significant variable. So directly I cannot take because it is string, but I can do some keyword mapping, which you will be doing with the if-else statements and then convert it into a yes, no, or maybe even more categories if you want to, up to you. But I would look into this directly, not, but I would do feature engineering and definitely look into this. Total years in the UAE. Maybe, yeah, why not? But again, I'll have to check the correlation with income. No, but that wouldn't be, it's not total income, so that's fine. Yep. So I have my first impressions already. Again, please remember when we do it in the class, we are not following a proper process as you should follow for your coursework too. For your coursework too, this is the most important part. Which one will you take? Which one will you not take? Do the research. Is it important? Is it not important? Are the variables correlated? Are they not correlated? This is the most important part in coursework too. Here, when we do it in the class, the objective is to teach you how to run the algorithm, right? So we wouldn't be spending 2-3 hours on doing a proper research. We would just do it on a trial and error basis. We'll say, okay, let's consider, let's not consider. But then in your coursework too, that shouldn't be the approach. Don't just switch on everything and run directly, or let's consider everything and see. No, this is where majority of your marks are. For coursework too, it's the research. Take every variable, argue whether it should go or not, do some domain knowledge, do some pivot tables, do some graph. In fact, much of your explanation prior to the model is this stage. So don't think that in class we are not doing that. So that's not required. In class, our objective is to show you how to run algorithms, how to see the result, not to go through the entire research process. So that concludes my first impression with the data. Once we come back from the break, now I will not tell you how to do. Majority of the process remains the same. You have your data, we'll prepare the data, we'll split it into train and test. Everything is the same as logistic regression. You'll apply the model on train, test it on test, choose the best trial, do multiple trials and deploy it. And then for an unknown customer data, where we don't know whether they will sign up or not, there is another data set. We'll bring that data set, we'll pass it through our model. This time we'll pass it through decision tree and then see the predictions on whether those customers will buy the credit card or not. Any questions? Before we take a break. All good? Okay, so 10:50. Let's come back at 11:05. Yeah, thank you. Sid, tell me.
Sir, based on the 60% you were telling about right
Yes.
now,
Mm-hmm.
I have run some models on that
Mm-hmm.
based on my data,
Mm-hmm.
and I'm getting a score in logistic regression and the random forest. I'm getting a score of 1.
We'll see. Once we get to that stage. We're just starting now.
Sure, sir.
Okay. Udit? Yeah.
Hi, sir.
Yeah.
So, in the research work,
Hmm.
it's mentioned to gather additional information and like in that, do we have to collect more data sets and link it to that?
Not necessary more data, but let's say, you have, let's say every row you have a date, and you have another data set which gives you the temperature of the day, and you can add like one more column, but that's not required. I mean, research is more on, for example, if I'm doing research on this, I would see if credit score actually impacts the decision to buy a credit card. What kind of shopping behavior impacts the buying of credit card. Yes, additional data can be done, but not something that you should break your head on.
Okay. If let's say I'm doing a research work on the car company
Correct.
and I am getting the stock prices for that
Hmm.
company, the date
Yes,
wise, I
correct.
can add that to
You
my
can
data set,
add
right?
that. Correct. So you can add
Okay.
columns, but not, source for additional data.
Okay. So do we have to mention the source of the
Yes,
data?
100%. 100%.
Okay.
Yeah.
Okay. Okay.
Okay.
Thank you,
All
sir.
right. Yeah. See you after the break.
Yeah.
But I am Totally, absolutely. Expressway, maybe. No, and still, not earning and such advertisement. At 1.5. Which is not as good. Some is expecting high. मतलब हमारे मतलब से फिर करेंट मिलने का 3-4 लाख तो कमाए थे थोड़ा
Hi. All right, shall we get started? Okay. All right, so just for the recap, I hope all of you have familiarized yourself with the data set. We are looking at customer data here. Every row is a customer. We are predicting whether the customer would sign up for the shopping credit card or not. And there are a few other interesting things which might emerge out from the exercise when we see the results. So I want you to follow step by step. What do you think should be the next step? Pivot tables, ideally, but as I said, just for the interest of time, I'm not getting into the research part. We'll just, based on logical sense, try and include some, maybe exclude some. And again, all of you can do different experiments if you wish to. Let's see who can build a much more logical model or higher accurate model. So you're free to ignore, you're free to include whatever variables you think you can, see how it affects the results and so on. But let's do the first trial together with the same things, everything select. Everyone selects the same thing. And then second trial, third trial is your choice on how you change, how you come back and so on. So now that we are not doing pivot tables, what should be the next step? prepare the data. So we should go for missing value preparation, creation of new columns. Hmm, hmm. We can change that in the prepare also. We can change that here also. Again, yeah, that becomes important if you're considering those variables as one of the important variables. We'll do that in the prepare recipe itself. Okay, so let's come back to the flow and let's go for prepare recipe for the card. We will name it card prepared or whatever you want to name. And let's get into the prepare recipe. Okay, now you should help me step by step. Is everyone with me? Prepare recipe. Let's have a look. Yeah. Yep. Just. Okay. So you were here. Okay, let's move column by column. Now, I will only tell you, and you will tell me what needs to be done. So first things first, are we looking at sample problem versus whole problem here? Whole problem. So that means no issues. It is 3,000 rows. It's less than 10,000, so that perspective is not there. That you're only looking at a sample. So one drama finish. Let's look at age. Can you tell me how many age values are missing in the column? How many? 30. All right. So in that case, 30 out of 3,000. What do you think? Mode or average, anything? Mode, I think, is also good. Mode would retain the overall distribution. Average might slightly change, but 30 out of 3,000 really doesn't make too much of a difference that you will with any of the methods. So let's stick to one. Shall we choose mode? Mode. Yeah. All right. So go ahead and replace the missing values by mode. What is the mode? 43. All right. So replace the missing values of age with mode. And if you need help at this point of time, that means you're not practicing. Well, this should now come naturally to you. Click on the column age, figure out where that option is, replace missing values with. Let's do it together. So here is age. If you see more actions, you would see fill empty rows with, and I would say mode, which is the most frequent value. And you can click OK. So that should be your step one. With income, how many are there? We'll come to income. Just four. Yeah. So then mode or average both are okay. So make sure that age is step one. We'll do one column at a time. It says double and decimal. Yeah, not an issue. Income. Let's move on to income. That's your step two. Income also has missing value. What do you want to stick with? Mode. Let's do mode. So income, more actions, fill empty rows with mode again. What's the mode of income? 20,000. All right. Yes. Great way of looking at it. And I would say in your coursework too, this is exactly the kind of narration that I want. So now we are just, reaching to a stage where I can show you what decision tree is. Ideally, you should spend time. And in fact, people form categories here also. So they would say, okay, where are these missing values coming from? What job type is it? What age is it? So for a certain age, they would click, okay, what is the average income and fill that as the remaining value. So that's the kind of research and brilliant thinking. So what she's saying is you can look at the type of the work based on the missing values and then take a better guess on what those missing values could be. Excellent approach. Exactly the kind of approach I want you to take in coursework two, where all this forms part of your research. Good thinking. As of now, I'm just, as I said, ignoring the research part, getting straight to running the algorithms. Yeah. Okay. Hmm. Hmm. Hmm.
So there is a manager, income is 70.
Okay.
Also a manager.
Makes sense. Yeah.
even to this class,
Correct.
I got the same thing
Hmm.
for the hackathon,
Hmm.
and then like, if you're not getting more and all,
Correct.
how sufficient?
Average of manager category. So let's say I do the analysis and do a pivot table where I look at all the job type and the average income for each job type. So let's say the average income for manager is 40,000. So I would actually replace 40,000 with that. That's the best way of approach. Because even in manager, there is variability. So average of the job type. Very early, sir?
I was attending
Online, all right, okay. Yeah. Okay, so step one done, replace age, step two done, which is income. Let's move on to the next one. Marital status, string and text is okay. Job type, string and text is okay. Has loan, boolean is okay. Credit score looks good. Visit to branch looks okay. You were telling about visits to branch, is it? Which it's fine. I mean, it's taken big integer, not required. I mean, you can have integer. Hmm. Analyze. Okay. But you have, yeah. So in if it is categorical, you can have a look like this. If it is numerical, you can have a look like this. So it shows you all. So fine. I mean, all the statistics are coming. Everything is good. Hmm. This one? Yeah, but that's okay as of now. Like I still get a good histogram. So nothing that will stick to integers. Yeah, no problem with that. Because you don't want it to be categorical purely. And I mean, you would want to see whether visits of the branch individually makes a difference. And since these are smaller numbers, if I see it 1 to 10, okay, not an issue. Average online spending, double decimal looks okay. Emirate looks okay. Children is fine. Okay, now let me give you a tough task. Total years in UAE also is fine. And our main dependent variable is Boolean automatically, yes or no. So which is also okay. It can be Boolean, it can be string or text, which is categorical. So Data IQ picks both quite comfortably. So, let's say, yeah, these are number of children, right? So integer. It's not categories that type one, type two, because let's say if you want average number of children, so you can still calculate that. So nothing that would disturb the analysis here. So it looks okay. And again, you can change it as far as, whatever you are comfortable with. I would retain because it does not cause any difference in the analysis. Okay, now let me introduce step number 3, which is where I would recommend you using GPT, Claude, or whatever. Now, let's keep it simple. Maybe later you can try more complications. Um, Let me pick up some keywords from in general. Let's do Amazon. Let's do noon. Let's do booking. And let's do Zomato. 4 things. Listen carefully. Noon, let me type it down. Noon, Zomato, Amazon, and what was the other one? Booking. We'll just use booking. Online student, someone was asking something.
Sir, I said Talabut.
Yes, we can stick to 4. You can experiment with that later. Talabat is also valid. Okay, so here is your task. Listen carefully. I would recommend using a formula, and I would recommend asking GPT to prepare that formula for you, unless you're confident to just ask which function can help you do that. But there will be or and all that. So I would recommend going for Gen AI to give you the formula. And what should you do is you should create another column called um, category shopping. Okay. And if the shopping interests contains one of these keywords, which is noon, Zomato, Amazon, or booking, contains one of these, then the category should be yes, else the category should be no. We'll keep it simple. If one of these four categories are present, then your new column should reflect yes, else the new column should reflect no. Anything, let's say category shopping, give any name that you want. Shopping category, let's say. That should be the name of the new column. Best to do a GPT or Claude and then ask that there is a column like this called shopping interest. And if the text contains one of these four keywords, then it should be yes, else it should be no. I will also search the same on GPT and check what it gives. 5 minutes to do this task. Amazon, Noon, Zomato, Amazon, and Booking. So it's a simple yes or no. Done? Okay. Once more. Noon, Zomato, Amazon, Booking. Just be careful with the capital. So in the shopping interests, I think, or the caps are used. Capital N for noon. I think Zomato is also capital Z. B is capital B, and Amazon is also capital A. So I could build the whole formula with GPT. Of course, be careful. GPT might give certain formulas which are not relevant for this. So, and the name of the existing column, you should also be careful. How many of you have completed? Okay, nice. And I see the formula. If else itself, okay. Oh, then you make it the whole thing. All right, that's fine. Anyone who did anything else other than if else? Can use the formula directly instead of if then else. Formula? Okay, which one? If, yeah, perfect. If you're not getting, don't worry, we will do it. I will share the formula with you. All right, let's do this. You can choose if you're doing if then else, then you can choose if then else. The only problem with if then else is you have to be very careful which one are you putting where and what is the else part and so on. I would rather prefer, and everyone, please, this is very important for your hackathon as well, because you want quick results. And with AI, why not take help of AIs? Everything is good. So how you should be prompting at this point of time if you're using GPT. So everyone, please be careful. I'm not going for if then else. Even if you have used if then else, have a look here, because later you probably will have to come up with formulas that you don't know. So the best way is to prompt GPT and inform that you're using data IQ. Number one, you have to inform GPT. It will not understand which tool you're going for. You have to give the exact spelling of the column, and you have to say, this is my column name, which is shopping underscore interest. Okay. And then you have to give your prompt. You have to say, if the shopping interest has the following keywords, which is known, Zomato, Booking, and Amazon, then the new column should be yes, else the new column should be no. And don't blindly copy and paste, just check everything, whatever the GPT is giving. And for me, when I ran the prompt, it did give a formula. So let's first see where to put in the formula. So I'll click on shopping interest. I will click on more actions. And called process with formula. If you're using if then else, and if you're comfortable with that, no problem at all. Otherwise, click on more actions, click on process with formula. And once you see process with formula, a new step will open here. It will say, what's the name of the output column? Let's name it. I don't want to replace it, so I will name it as a new category or shopping category, whatever you want to name it. And then I will say, click on open editor panel. Okay. And that's where I will start putting in the formula that ChatGPT gave me. If at all you don't want to put the formula and you want to try yourself, you can try on your own. If and then there is a or function which can combine multiple things together. And then there is a contains function which tells you whether a string is contained in another string or not. But why get into all this when GPT can give you the function itself? So when I ran on GPT, it gave this, which is very simple, which is the correct one also. And you can try this until you get this. So I paste it here. There you go. It directly gave me this formula. If, or, and then contains shopping interest noon. So basically it's combining all these four into an or operator. If the answer is yes, then yes, else it is no. And it works 100%. If you're not able to prompt it, at least now you can prompt GPT that use only the following functions. If contains an or, and give me the formula with nice brackets and everything. It will frame the formula for you. Just copy and paste. Before you apply, check your preview if you are getting. So for example, in the first one, there is booking. So it is yes. In fashion brands, groceries from Spinneys, it's a no because none of these words are there.
So I
Yeah.
have pasted a formula in the chat. I think it's gonna give the same result if you can check
Yeah,
once.
yeah, absolutely. And there are multiple formulas contains. Yes, that's the
It
or
is-
operator, by the way. Yeah.
Yeah.
So, guys, that's a good point. It's not just one formula that applies. There is a or operator if GPT is giving you that, and with that also it works. There's a contain like or could be used as a function. There are various ways. Whatever works for you, just apply. Check. I mean, don't apply. First, copy and paste the formula. Make sure the variables are picked up correctly. Make sure the syntax is valid and just make sure that you're getting the preview right. Yes or no? And
And
if
so
you, yep,
one more
yes.
thing.
Mhm.
Like here, we just figured out by overlooking like noon is in capital N, but
Correct.
if the data is huge and maybe
Hmm.
then and noon is in small.
There is a formula which converts everything into lowercase or converts everything into uppercase, and then you could use a contains. So you
Yeah.
will have to use one more formula in that case. Correct.
Okay.
Yeah. And for those who are online, I can put my formula also in the chat. You could use any one of these, all are the same. And those who are here, let me know if formula doesn't work. Okay, yeah, I see. Yeah. What formula are you trying to with GPT? Use it. No, did you mention you're using data ID? So I don't know. Okay. Did not mention what's your column name. I want to add a column. You didn't mention the column name, so I'm better to use GPT. And mention the name of the column is shopping interest. Name of the existing column. Shopping interest. Make this correctly capital S, which will all you can call. If it's fixed. Then just mention no, but don't use lowercase. You done?
Yes.
Yeah, okay. Four, one. Okay. All right. Yes. Restart. No. If or uh, need the we have GPT. No? Okay, this uh,
I just like,
better to format it because there are many brackets and everything. So just ask GPT use if or and contains and give the prompt. Yes, you're good. So yes. So which method are you? Okay, sounds good. So first of all, you need to give a new name to the output. Okay, so name and address. Name should be which option you can select? It looks for any first. Right? That is your. It should be okay.
Sir,
Just the formatting. Gemini is not very updated. Yep. Yes, online students, yep, tell me.
Professor, when I copied the formula from
Mhm.
Claude,
Mhm.
it's saying parsing error when I correct when I.
You can just copy the one that I put it in the chat.
Okay, thank you.
Yeah, just delete it and put this. Yes, who else has not done? Yes. Yeah, that's fine. That's fine. Different ways of handling, and the only problem there is capital letters and capital, right? So you can choose and that change it to capital, change the column. Let's copy. Yeah. All good? Is still. Better because there's a lot of brackets and formatting. So
Yeah, no, I did.
yeah, fair.
Yeah.
No, so this is Python. You didn't mention data.
I did mention it.
First mentioned the column name is.
That might make us into the approved GGD guys.
And capitalize show the letter and in the front first letter on. Yeah, and then should
Do we have any more for?
Sir, college ID, no. We generally use, for data science, we have the Amazon and Google account, which gives you like $100. I don't think for business we have. We'll see, I think we should.
If we are in.
Hackathon free is more than enough. Yeah, with just one or two formulas you would need, and even if you go on. Yeah. That's because. Get a plan. That's yeah. And all right, so now we have a new category, and again, this is something that you should develop as a practice. Everyone, please pay attention. This is something you should develop as a practice in terms of prompting nicely, telling data IQs what you're using the correct name of the column. Don't blindly copy and paste everything that GPT is giving. Out of all the LLMs, I would say don't use Gemini. It's not very updated with data IQ. Claude or GPT does the best for understanding. It's pre-trained already with data IQ. So don't use Gemini would be my recommendation. Or either GPT or Claude for any of the formulas. Again, if you can do it on your own, there is nothing better than that. But when too many brackets and everything comes, then you start getting confused. Another way is you do it yourself. And just for the formatting of the bracket, you can paste it in GPT and say, can you format it with the proper bracket? So lot of ways in which you can customize the formula. But again, just make sure that you're prompting everything correctly, making sure that you see some of you are not even seeing the steps. So keep a track. This was step one. This was step two. Now you're on step three. If you make any mistake in any of the step, you need to delete that step, particularly for two of you. Yeah, you didn't see that there was a step three in between, which was causing a problem. So always keep track, apply proper changes, make sure you're naming your columns properly, so everything will be on track. Question, online students, this IFSA? Was that the previous one?
Yes, the previous one.
Okay, all right. So let's go ahead and run the changes that we did. And let's come back to the flow, and I'll give you then the next task. So in my case, data preparation is done. I have a card prepared. Come back to the flow, verify that the changes are done. So right now we are running the changes, prepare recipe is done. Make sure you come back to the flow. Make sure there are two blue boxes that you see. And let me know if anyone has not seen. All done? Anyone needs any help? All right, moving on. Now your next task is a bit complicated because I want you to find a new option. Listen to it very carefully. Now that the prepared stage is done, what do you think is the next step before running the algorithm? What do we do? What did we do in logistic regression? Split it into training and testing. Okay. Now, here is your task and listen very, very carefully. This time, I want you to split a bit differently. Okay. Last time, do you remember how did we split? Random. 80% went to trains and remaining 20% went to tests. This time, what I want you to do is use the same recipe, which will be split, where you split it into train and test. The only difference will be in train, you'll have to do the following activity and listen to it very carefully. First, you need to sort the customers with with customer ID. I repeat, you have to sort the customers with customer ID. Okay. And the first 80% of the sorted IDs go in train. And the last 20% goes in test. It's not random. I repeat. Let's first see if the data is already sorted by ID. Let's check. Let's check customer ID. Yeah, it's already sorted. So which means what I'm trying to do is first 80% goes in train, last 20% goes in test. Let's see. Nothing extra to be done. It's just the method of split. Still the recipe remains the same. You must use the split recipe, name it as train and test. Everything is the same. Go ahead, use split, name it as train and test. If you're not confident, wait for me to do it. And then once you are inside the recipe, last time we chose random as a method of splitting. This time I'm going to sort the customer ID and the first 80% of the records will go to train. The last, sorry. So in the sense, it's already sorted. So basically I can choose, for example, I can sort by age. And I would say, okay, if you have sorted the whole thing by age, the first 80% is going to train and next 20 is going to go by test. Done?
And before applying them.
Let's check. That's correct. That's correct. Good job. 80% train, 20% test. Who had question? Yes. That. Which one? Or the can you show me the recipe? No, just show me the recipe. Yeah. Salt, ready? Perfect. All good. Yeah, I'll show you. Now that's not very complicated. Let's do it. So I click on prepared. Make sure it's clicked on prepared. Everyone, I'm doing it now. Please have a look. Guys, I'm doing it now. So click on prepared. Click on split. And name it as train should be first. Test should be second. Make sure you have prepared. You have train and test as the two output data set and click on create recipe. Last time, which option did we choose? We chose randomly dispatched data. This time we are not going to do that. We will do the last option, which is dispatch percentiles of sorted data. So let's click on that. Now it would say, how do you want to sort the data? According to which column? According to age, ID, or what? So we'll select customer ID. So it will sort, it's already sorted, but it will sort it again in the order. And then You can choose few more options that after sorting from customer ID, sort according to age, sort according to that. But we just need one sorting, all done. And we'll make the ratio as 80%. Done. As simple as that. So 80% after sorting goes into train. The last 20% goes into test, a different training and testing strategy. And again, in hackathon, we can specify that. We can tell you that in this case, you have to do let's say a sorted split, you have to do a random split. In your coursework too, you try everything. You try sorted, you try random, see if it's making a difference. So that's part of your research in coursework 2. And that's it. I click on run and get ready to run my algorithm. Just double check everything. So when you double click on train, you should have 2,400 rows. When you double click on test, you should have 600 rows. So it got split into 2,400 versus 600. Anyone who did not get? Need help? All good? That's it. Train and test, yeah, all good. Run it. Go back to the floor. Yep, all good. Yep. Time to run decision trees and see how this model would turn up. Where would I run decision tree, on train or test? Train. Let's click on train. And which option? Now you know the option. Auto ML, which is in lab option. So click on train, click on lab. Let's click on auto ML prediction. And what are we trying to predict here? Signed up CC. That's the last column. That's what we are trying to predict, which is whether a customer signed up for the credit card or not. And which option now? Choose algorithms, correct? We are going to choose our own algorithm. You can name your analysis if you want to, or just retain the name, does not matter. So I can call it, today we are doing decision. Mostly because these are for, if you have to build a quick prototype, it will suggest, again, if you're doing deep learning, you can choose that. Choose algorithm as the most comprehensive thing. So even deep learning, you can choose here, even the prototypes you can build here. Everything can be done in choose algorithm. So always for you in the module will be choose algorithms. So that's when you have your own algorithm. So let's say you have a code which you have made a different form of decision tree with some other mathematical indicator. You can use your own estimator model and then bring it inside. But no one is doing a PhD here, so we'll use existing algorithms. Okay, so that's it. And now we are in the design stage. Remember the design versus results. It's exactly the same. Let's start from where we usually do. Let's go to target on the left hand side. Make sure that signed up CC is selected as your target. That's what you are predicting. What should be the next? Before that, train and test. I would love to make sure everything is correct. Now, do you think the policy is selected correctly? The policy of train and test, by default, it has selected split the data set. Yes, same thing as logistic regression. We have already done it, so we don't want them to do it now. We have already done train is separate, test is separate, everything is good. So I select on policy and I click the third option. Explicit extracts from two data sets. I can put train to train, test to test, and everything should be good. So when I do that, train is train, sampling. Should I do any sampling? No sampling. And again, even if you leave it, it's not a big problem because it's taking what, 10,000 rows. We have only 3,000, so it shouldn't affect. But just as a good practice, say no to sampling. So train is train. Let's come to test. And let's click on test. Train goes to train, test goes to test. Even in test, I don't want any sampling. So I would select no sampling. And just make sure that train is train, test is test. Everything is good over there. Now let's come to what Aisha had mentioned, which is features handling. Let's click on features handling. Customer ID switched off. Should it be switched on? No, we would never take ID. Age are we taking? Yes, let's go ahead. Income are we taking? Yes, let's go ahead. Marital status? Maybe. Yeah, let's keep it on. Job type, we'll switch it off. I don't want job type right now. Has loan, we'll keep it on. Credit score, we'll try. Visits to branch, no, I would not want that. Average online spending, we'll keep it on. Emirate, I mean, let's keep it off. Later in your trials, you can try again with Emirate on. As of now, let's keep it off. Children, no, let's keep it off. In the trial, you can keep it on. Shopping interest is anyway rejected because it was a text variable. And this new thing that we have created, which is shopping category, we would want to keep it on. And again, I'll tell you once we see the results on what you should be careful about. But right now, shopping category, I'll keep it on. Total years in the UAE, maybe. So let's keep it on. That's it. Let's move on to algorithms. Logistic, I'm switching it off as of now. Later you can, in your second trial, maybe you can switch it on. But if you want to run both together right now, you can do that. I'm going to switch on decision tree. Random forest, maybe in the next trial. Let's only run decision tree. In the next trial, you can switch on random forest as well as logistic regression and then run. Right now, let's focus on decision tree. Then it will be your homework. You can try logistic regression, compare the results, and so on. What else? That's it. We can save and we can train. We'll call this as trial 1. And we can train. Yeah. That's fine. I'll tell you later what the options are. Everything is clear. Yeah. It will, like even in logistic regression, did you see the coefficients on the front screen? No. So we click inside the algorithm, we see the detailed results. Right now, these are front results. Just like logistic regression, these are the results that come in the front. What is the first thing that we notice? What you should notice right now? First thing that you look into.
Income is helping a lot in figuring out.
Yeah, even before that. 0.912, the champion icon over here, that tells you that it took your decision tree, it ran it in your test data, compared with the actual results, and the accuracy turned out to be 91.2%, which is a great accuracy compared to the fact that we haven't done much. We didn't experiment much, we didn't do too much of data prep. Even without anything, 91% accuracy, it looks like. If you look at based on the tree, what data IQ is interpreting is income, total years in UAE, and has loan are probably the top 3 variables at this point of time. Not necessary. I'll tell you what the depth is. He also asked the same question. Can I reserve this question till we see the results? I'll talk about what depth is. Depth does not correlate to the number of variables. It is the number of levels on the tree. So in one level also you can have 6 variables. left hand side there could be something, right hand side there could be something, then there could be 4 here. So the levels are basically level 1, level 2, level 3, level 4, level 5. And I'll tell you why they keep a cap of 5 and why you may not. I'll talk about the depth. So as of now, I see which variables are the top variables, but as Aisha said, I don't see the tree yet. Where do we see the detailed results? We click inside decision tree. And then you see everything that you should see. And you notice a difference. In logistic regression, when you went inside the results, instead of decision tree, it was regression coefficients. You don't see regression coefficients here because there is no beta x1 plus beta x2. There is no equation. However, now stay with me, everyone. Few things remain the same. Number one, what if analysis? Exactly the same. Choose a profile of a customer, live predictions you can see on whether the customer will sign up. And this is great for the bank. So I would say, okay, there is a customer who has no loan, who has an income of 46,000, whose online spending is this, whose credit score is this, whose total years in the UAE is this, so on and so forth. And you can keep on changing the customer profile. And for that customer, you get a live prediction, which is whether the customer will sign up for the credit card or not. Guys, please do that later. First stick with me. Questions on this? Correct. Now, this is where again I told you this is not the actual probability of the algorithm. It's an interpreted probabilities based on the tree on how much was split on the left side, right side. In decision tree, I wouldn't consider this as a great thing. I would only say yes or no is the main thing. It's an interpreted probability, not the actual predicted probability. So I have to be a bit careful over there when I see that. For those of you who are wondering, where is the tree? Here is the tree. When you click on decision tree, and I don't think it's a complete tree, you can expand all and then see the whole complicated tree. And again, you see it started with has loan. So has loan appears to be one of the very important one. Income appears to be important one. Average online spending appears to be important. And then all the drama of look at this, look at that, and so on. And then finally, you get a prediction of a red or a blue. Blue stands for yes, red stands for no. The complete if else is already ready. I would also look at confusion matrix, very important parameter for me. There were 600 rows in my test data. Actual predictions were 529, and I mean actual thing was 529 and the real one was also 529. There were this green. Actually the answer was no, predicted answer was no. There were 28 and 37 plus 6 was the error term that or the errors in the prediction. And that's why the accuracy came out to be 91%. Nothing changes. So that means they were not important at all. That's how you experiment. Now you add, you delete, you say, okay, what can be added, what cannot be. Now, one question, and again, I leave all the experiments on you. You can try logistic, you can try random forest. But at this point of time, as an analyst, looking at that matrix, I'm a bit concerned. This is what I want you to work in coursework 2 as well as a hackathon. So, yes, the output came, 91% came, thing looks good. I am a bit concerned. Threshold number 1, yes. Now, again, as I said, probabilities and decision tree won't make too much of a difference. But yeah, that is a very weird threshold to say 0.05. And obviously, you know why Data IQ has done that because it wants maximum accuracy. Now, does that probability threshold actually make a lot of sense? No. But does that change a lot of things? No. I mean, slightly accuracy gets compromised, but not too much. So not too much of a concern. Still, there is a big concern. What is that? Correct. Correct.
Almost like a 55 to 45% of
Yeah. So let me explain. Very close to this. Let's do one thing. Let's come back to yeah. 0.5. Okay, let's come back to where your results were. Point 0.05, right? These are your results, correct? So now I would look at this and I would say there is only one problem here. Majority of the predictions are yes. Have a look. Now, if you see out of 600 and see this column, predicted yes, it has predicted 566 as yes. And someone who would come here and ask you a very interesting question, they would say, forget about your model. Why did you do all this drama? I have a better model for you. And you want to listen to my model? I would say everything is yes. Give you whatever customer, I would say they would sign up for the credit card. Even with that model, I could achieve great results. Are you getting my point? Now the problem is that out of 600, the actual yes were already 529. And this is not a great test data set to play with. Ideally, if the test data set had equal number of yes or no, only then the algorithm can show its real power. How much of yes is yes, how much of no is no. But now, out of 600, if your actual yes, in fact, how many are total actual yes? 535. Out of 600 are already opting for the credit card. Then what great power the algorithm has. In fact, I don't need decision tree. I have my own algorithm which says every time it will be a yes.
how that is.
And it is, so which one?
So the existing data,
Hmm.
if 535 out of 600 are saying yes,
Hmm.
then the algorithm is trained on the data.
But this is test data. This is test data. It was not trained. So the problem is now I would sit back and think, when we split the data, did it so happen that majority of the yes actually came down in test? And I would say maybe my splitting was wrong. I should have done a random splitting here so that my test data had a good mix of yes or no, and my trained data also had a fair mix of yes or no. Even if that doesn't work out, I would say, can I reduce my training data a bit to make sure that test data has enough number of yes or no? Or maybe I could change the split strategy completely. I could say do a stratified split, which means in the trained data, maintain the ratio of yes or no. In the test data, maintain that ratio of yes or no. As of now, while you can be happy and you can say, job done, I got a 91% accuracy, my model is great, it is not, because there are only 65 out of 600 who did not opt for the credit card, which is partially okay. The other argument is yes, there are only 65, but out of that, 28 were correct predictions of no. So someone could also say, no, there is some merit in the model, but I wouldn't be extremely happy because it's heavily biased. And this is how analysts should think. It is heavily biased with the actual predictions being yes. So can I go back, change the testing and training strategy, make sure that it's not like there can be majority, yes, there's no problem with that. But extreme majority, like 535 out of 600 is already yes. And if the model is also predicting already yes, it might not be a superb model. And this is where I would raise question marks. Unlike the Titanic one, where there was a good mix in all the things. Yes, yes, also there was good numbers. No, no, also there were good numbers. And that looks okay. The model is doing a fair job in predicting a yes or no. Here, majority predictions are 566 out of 600 are yes. But that does not mean the model is bad. The model could have been bad if this was 0, which means there were no predictions in the no category at all. Right now, at least there are 34 predictions in the no category. So it has some merit, but have to be very careful in seeing this biased nature. In fact, what I would do, Utkarsh,
Yeah, so when I check the data which we worked on, so the no percentage is like 10 only.
exactly where I was coming to. This is exactly what I was telling. In fact, what I would do next is go back to my data and check how many are yes and how many are no at the first place. And some people get too curious. Now what they say is, look, this is a heavily biased data towards yes already. Can I make a smaller sample of this data? So, can I have, so let's assume what percentage you said is no. Let's see the actual number.
10.5.
Okay, so let's see the actual number. Let's go back to the flow. Let's see card prepared and let's see the last column. And that's how analysis is usually done. So I go to analyze. I see there are 2,682 yes and 318 no. One strategy that I can do is maybe form a sample of 900 or 1,000, where I take all the no's, definitely 318, and reduce the number of yes, and then try and run a model. That would increase the percentage, that would reduce the sample, but increase the percentage of no's compared to the yes. That gives a fair chance to explain, is the model really doing good as a model? Or is it doing good because the data is in such a way? All this is part of research, right? And this is exactly the difference between coursework and hackathon. In hackathon, you wouldn't go so much back and forth, but in research, in fact, I can tell you honestly what will happen now. Majority of the models that you run, you will see 95%, 99%, and you will think job is done. There are problems. There are some things which are leading to that, and that's what we want to know. So see my strategy now. I will retain 300, and from 2,682, maybe around 500 I would sample. Total around 800, 900 records. Let's run a model, same model on a smaller sample, but significantly larger percentage of no, and then check, do I get the same accuracy?
Can't we do random sampling in this?
Random sampling you can try, but as Utkarsh said, originally itself it is so low. So even in random sampling, very high chance that again your no thing would be really low.
So, so
So percentage should still remain 80-20. So that's not a thing. The original sample, which means when I reduce the sample size here, can I make another data? And again, you can use a recipe where I retain the no's and then take probably half of this or maybe 40% of this and then make a data and then run the model on that. A lot of experiments can be done. Yes, someone online was asking.
yeah, so I'm saying that if we are doing this, then if we're taking, see, no is 318, shouldn't we take yes as 318 exactly?
Not exactly 318, but maybe even more than that. So it need not be 50-50, but it should not be in extreme minority.
But
So
if
even
we take 50-50, then won't it make it learn more precisely? Like if
no,
we
but
take
then the number of training rows will reduce. So let's say you take only 318 of yes. So total sample is only 600, correct?
yes.
Yeah, so I wouldn't want to risk that. So maybe instead of 300 yes, I would take 500 yes or maybe 600 yes, which would still give good percentage, but not lower the sampling so much.
Yeah, okay.
Yeah, good question. So, yep. So resampling is now you can't do with a split. Now what you have to do is there is a filter recipe. Sample and filter. So from the filter, you would randomly take some percentage of the yes and retain the complete no, and then make a reduced sample, which you can try. You can do it in the original data itself, the prepared one, and then do a training and testing of once you make that new sample. Multiple options. These are all different pathways. But as an analyst, I would love to check. I'm not completely happy with what I see here. I would love to recheck whether the model truly stands on its own or is it because of the biasness of yes and no. With that, we come to the end of the session today. I leave other things on you. Try logistic regression, try random forest, rerun, see if you can notice the differences, try and include, exclude some variables, lot of ifs and buts. But now you know how to run a decision tree. Thank you so much. I'll see you all tomorrow.
Can sample in this, like, you have to put it in the algorithms?
No, so there's a recipe called filter and sample from where you can. I can show you next class. We can do that. Any other questions? Anyone couldn't do this part? All good? All right. Thank you.
So I have
Yeah.
one question.
This
So
one. Yes.
when we'll be doing the coursework,
Hmm.
then should we be doing the preparation on the whole data set or just the sample?
Whole data. Definitely whole
Okay.
data. And then see if you can rerun the model with the sample if required.
Like we figured it out that the whatever we were figuring out, the majority was yes,
Hmm.
and so we will resample it again. Like
Exactly. If required, resample.
if
If
it,
from starting itself, we don't.
okay. So will
Yeah.
you be telling it this in the next class? Like
Yeah, I can show you the sampling. Yes, definitely.
okay.
Yeah.
Thank you, sir.
Okay.